Okay, so remember, you're doing me a little favor because I helped you out with some mindfulness, right? So I would like you to remember what standard form is. But remember, I got the pink thing that shows you the parent function. And buried within that, we have a couple different things that happen, right? So I took and I put an A in front. And I told you that controls the width. Oh, it stretches or it compresses. Yeah. Then I put a number at the end back here. And I told you that's the vertical shift. Oh, that shifts it up or down? Yes. Okay? So I want you to think about all the things we've done so far with a parabola that we can. We've shifted it up and down vertically. We have flipped it upside down. We've stretched it and narrowed it. What's the only thing we haven't done? So we have not shifted it side to side yet. So if you think about it, where have all of our vertexes been? Right on the y-axis. Today we are venturing away from the y-axis in moving horizontally. So if you stay with me, is it your question about what we're talking about?
Yeah.
Okay.
Would you change the X
No, the X one, it does not change. But what do we notice is not written in this form right here? Yes, awesome, guys. So every equation, I don't know if you noticed it, but all the equations I've given you was missing this middle term. So now we know that is involved. Hello? Hi. Yeah, can I call you right back? Okay, yeah, sorry. Bye. Yeah, not ready for a conversation right now. So this controls the width. This controls the vertical. This controls the negative positive reflection. Now that we have that, we're going to see some horizontal movement. It's actually really, really easy. So let's just kind of write ourselves a little reminder. Let's put that this is our y-intercept. Okay? This here in green, that controls the width of it. Okay? And now we're going to learn that when it's in standard form, and now that we have the introduction of this, you're going to see some horizontal shifting. Okay. It means that there's going to be horizontal movement. It's not as easy as, oh, that's a 6x, it moves 6. It's not. Okay? I wish it was, but there's a little bit more to it than that. Okay? So stay with me, we'll get it. So the first thing I need you to know is when you have a full standard form, 3 terms, there's a little more to it than that. Okay, and I want you to think of the vertex as the king. The vertex is like the king of the parabola. It's the point. Think about all the vertexes that we've seen, right? It kind of leads the pack. So it's like, here's the king and all its people. I know I use such stupid examples, but hopefully they remember. So here's the vertex, and here's all of the points that go with it, right? Okay, so that's why it's the most important thing, because it's like the leader. And without a leader, what do we all do, right? So, finding the vertex is a little bit tricky, all right? So, here's how you're going to find the vertex. And actually, what I want you to put on your side over here is a little box and put V equals, ordered pair, X equals, okay? Because today, this is the final piece of the puzzle that we've been missing. I've not taught you that yet. You know shifts up and down, you know widens and all that stuff. Okay, so to find, because the vertex consists of an x value and a y value, right? So to find the x coordinate in the vertex, you're going to use this formula. The opposite of b over 2a. All right. It's just a little something you're going to have to just keep in your mind. The opposite of b over 2a. This means find out what b over 2a is and then take the opposite of it. Okay? And I know you're like, well, a, b, and c. You know what a, b, and c is. It's right here. So I'm going to give you this example. I want you to skip a couple lines here on your paper. Put y equals negative 2x squared plus 12x minus 7. So my A is -2, my B is 12, and my C is I really don't care right now, right? I mean, I know it's -7. I don't need it right now, but all I want right now is my A and my B. So watch what I'm going to do to find this value. I'm going to take the opposite of whatever the B is over the 2 times whatever the A is. I will tell you that the hardest part of this lesson for some kids is there's so much simple calculations with negatives that you do it in your head and kids are getting it wrong and not wondering. So 12 and 2 times -2 is -4. And then 12 divided by -4 is -3. And then what's the opposite of that? 3. Okay. Now, that's a whole lot of work to show. You could probably skip one step in it. You probably don't have to write this out. A lot of kids just go right to this because they look at the A and they multiply it by 2 and they put it there. Do you know how much you can do without losing it? Yeah.
So pretty much what you could do is you could literally write 2 out of the 4 steps.
Yes, you could do, yeah. Okay, so now let's get this. What did I say? To find the x-coordinate of the vertex, you use this formula. So this is my vertex right there. Okay? Did I do something wrong here? Because, yeah, okay, never mind. I said negative, put positive, because I'm like, that's supposed to be positive. So that's 3, not -3. So erase that if you had it. Because the opposite of -3 is +3. So what I want you to do right here is point to this spot and put this little formula. Because that is how you find part of your vertex. Okay? So now that I know that, I want you to watch what I'm about to do. So I have this nice piece of graph paper because you're going to have to graph it. And what do I know so far? Tell me everything you know about that parabola. Does it open up or down? Down. Is it going to widen or narrow, or is it standard? Widen. It's going to narrow. Okay? Because if it was standard, there wouldn't be anything there. What's the y-intercept? Is that still the y-intercept? Yes. So let's do what we know so far. So I know the y-intercept is a -7. Good so far? Yeah. I know that part of the vertex is 3 something. Watch what else you know then. It's going to be 3 something. It's going to be somewhere here. So what you need to know is, isn't the vertex always on the line of axis of symmetry? Watch. This little dotted line is going to be amazingly helpful for you. What is that called? The axis of symmetry. Okay? So I'm hooking my graph up with everything I know so far. I know the y-intercept is -7. And because I just found that out, I know that my axis of symmetry is 3. You want to see the easiest part of this? As soon as you figure out what that is, that goes there too, doesn't it? Right? Because if your vertex is 3 comma something, then your axis of symmetry is this. So you know why that's so helpful? Because I know my y-intercept, do I also know the mirror image point? So if this point is 3 away from the axis of symmetry this way, without even doing any math, I have that. All I'm missing is the y value. I got to know, where do I put it? So, how does that go? It goes like this. If you know one, plug it in to find the other. So plug it in where? Plug that x value in for all the other x's? Yeah. And this is the hardest part that kids rush through, and every error I fixed today in my first and second hour, they're like, it's wrong, I don't get it. Yeah, you get it. You just are trying to do too much in your head. So watch, please. So I am going to put 3 in for both of those. So I'm going to say y is equal to -2 times 3 squared plus 12 times 3 minus 7. Don't try to go from here to an answer. At least give me one more line of work. Let me show you what I mean. And don't try to plug that into a calculator and expect it to tell you the perfect rosy answer, because there's always something with negatives going on. So, this is the hardest part. Do I do -2 times 3? No. And then square it? No, good. And you can do this all in one step. 3 squared is 9, and 9 times -2 12 times 3 is, and then this is this. And then at this point, I'd like to see you that far. You could do the rest of that in your head, or guess what? I know you know how to add negative numbers. Grab a calculator and punch it in. Or for some of you, it would be quicker to do it in your head by the time you actually got up and got a calculator. So that's going to be what? 11. Okay. What is 11? You did it. You said 11 like 30 seconds ago. So when my x was 3, my y became 11, and I have everything I need to graph it, right? So I'm going to say 3, 11. And I have my vertex, I have my axis of symmetry, and I have my mirror image points, and that's all I need to be able to graph, okay? Because eventually, there's 5 key players in this game. The vertex, the axis of symmetry, which is new today. Y-intercept, we know. We know whether it opens up or down, and we know if it's a maximum or minimum. When you get this tomorrow, you're going to ignore graph number. I was having you match graphs to problems, but so these 5 things, I need to know if you're good on how to find those things, okay? So that was example number 1, all right? So there are going to be other examples where sometimes things don't work out how you want them to. So let's talk about this example. Let's say y is equal to x squared plus 6x plus 7. All right? So the first problem I always show you is always the longest because I got to talk a whole bunch through it. We're going to go a little faster. So today, the new piece, you know what, you don't need to describe anymore. You don't need to tell me that opens down. Just show me. So I do want this box, though. I want to know the vertex, and I want to know the axis of symmetry. So if you're doing anything new today, it's learning those 2 things. Those are the key players right here. So my A is 1, my B is 6, my C is 7. That's my y-intercept. Great. Yes. So we don't need to tell you that it's wider than the y-intercept. Well, we'll talk. You don't need to tell me that stuff. No. Okay. So I'm looking for this value right here. And I find that by doing the opposite of b over 2a. So let's try to fly through this. The opposite of 6 over, I'm going to do this in my head, 2 times a, if a is 1, is 2. What's 6 divided by 2? 3. What's the opposite of 3? Negative 3. And that goes there. Okay? Now, hold on a second because something's going to happen that stinks a little bit. Because some of the problems I give you, the graphs are pre-drawn, right? So what's the problem with this graph? Well, I know that my vertex is negative 3, which means my axis of symmetry is x equals negative 3. Go ahead. Yeah, well, actually that is a little bit to do with it. So he said the graph only shows one side, but guess what? In a way, I kind of don't like these graphs because they give you big hints, don't they? Meaning, if you mess up, it's not, I don't like it. You know that it's supposed to take place over here. If your points have you a vertex all the way up here, you know you've miscalculated. But here's what kind of stinks. I'm about to find my vertex. What is the point that I want to use for my y-intercept? 7. Look at your graph. How high does your graph go? 3. So, listen, do not go all the way up here and put a point at the very tippy top of your paper and say, oh, that's 7. There's a better way to figure it out. But before we even get to that, we got to figure out what our actual vertex is, right? I know it's somewhere on that dotted line. So what do I do with that? Negative 3. Now I got to plug it into all of those. So y is going to equal negative 3 squared plus 6 times negative 3 plus 7. This is 9 minus 18 plus 7. 9 minus 18 is what? Negative 9 plus 7 is, okay, awesome. I got my vertex. It's negative 3, positive 2. Okay. Oh, it is negative 2. I just looked at negative 2, which actually is great because look, is this going to open up or down? up. So if this was my vertex, they drew a pretty crappy graph, right? Do you see how you could use that to help you? Because I know it's going to open up, doesn't it make more sense that my vertex is down here? Okay, so here's your dilemma. What do? I have a nice, helpful point here, but my graph isn't cooperating. So you got to fall back on something I taught you yesterday. The width. What's the width of this? It's the same as your standard eyes, nose, right? So what's the coefficient here? Your A is 1. Oh, awesome. When your A has a standard width of 1, it's just nose and eyes, isn't it? So as soon as I have this one, then I know this one because this is my standard. Be careful, these graphs are cut into halves, right? So that's option 1. Option 1 is throw that y-intercept down. Use that y-intercept to find the mirror image. You got your vertex, call it a day. But what if your y-intercept isn't available? Then you have to use the width. You want to know what the worst of all that could happen? What if, because when this is 1, you're good, right? What if your y-intercept doesn't show, and that's not 1? And you need another point. You think about it. If you need another point, then pick one. Right? If you pick an x value, all you have to do is plug it in to find the y. Right? So, let's take a look at this one. What's my y-intercept? Negative 16. Where's that on my graph? All the way down at the next problem. Oh, that's all right. I'll just look at the width. Oh, shoot. It's not standard either. So, let's start from the beginning, because I know what's going to happen. People are going to come through, and they're not going to know how to do this one. So, 1 second. Let's do this. So, I want my vertex and my axis of symmetry. Okay? So, go ahead and copy this problem on your notes. It's number 8 on your practice sheet today, which will be nice, because then it's done for you. So, I find my vertex by doing the opposite of B over 2A, which is going to be 12 over, okay, yep, right here. This is going to be what? 3, because you got negative 3, and the opposite of negative 3 is positive 3. All right, guess what I would do? As soon as I know that, then I know my axis of symmetry is x equals 3, and I'm going to draw my dotted line right now, because that is a huge visual helper, because I know that this is my exact halfway mark, and I know my vertex is somewhere on that line. And I know as soon as I find one point on one side of it, that I just got to find the other. But I got to finish the vertex first. So, what do I do now? I put 3 here and I put 3 here. And I be very, very careful. Okay? Plus 12 times 3 minus 16. This is 3 squared is 9. 9 times negative 2, 2 times, or 12 times 3 is, and then negative 16, all in your head, somebody real quick. Oh, heck, hold on, we did something wrong, didn't we? Wait, where are we at? Oh, yeah, thank you. I was going to say.
The answer's 2.
Okay, so the answer, all that works out to be 2, which makes way more sense. All right, we're getting somewhere. Stay with me, this is the last example. So I'm going to go to 3, 2, we're in good shape because the vertex is pretty high up on the graph because of what? It should open down. But last time, okay, here's your first option. Option 1, if your y-intercept is on the graph, use it. It'll be the easiest way every time. But I don't see a negative 16. Shoot, can't use that. Option 2, look at your width. If it's standard width, what would I do from here? I would put one here and here, and I'd be done. Option 3, hopefully you don't have to go to this far down in your options, would be what? Pick an x, meaning let's choose x as 2. I'm just going to make x 2, because you know why I'm going to choose 2? Because it's right on the other side of my vertex, and it's not going to be off the graph. And the only unfortunate part about that is I have to go through this whole process again with 2. Okay? So I'm going to say negative 2 times 2 squared. Plus 12 times 2 minus 16, which is going to be 4. And then that's going to be 24. And that's going to give you what? 0, right? So guess what? If I know that this is 2, 0, then I know what? That the other one is actually 4, 0, because it's got to be the mirror image of that. Okay? Yes.
Now, how do you know which one's the better number to pick?
I would choose, now, okay, so that's a really great question, because if you do get to this point where all of your other options are not easy, then I would always choose one number that's on either side of your axis of symmetry. I always go with smaller numbers. It's just going to make it easier, okay? I want to do just one more quick one with you to show you that, and I'll just cruise through this one and just watch me. So y equals 3x squared minus 6x plus 2, okay? So my y-intercept is 2. Awesome. It's nothing crazy like minus 20. I'm pretty sure it's going to be on the graph. So this is a really easy one, okay? So the opposite of b over 2 times a. I just did that. That's 6. That's negative 1. And the opposite of negative 1 is positive 1. So that's my that number, right? Which means my axis of symmetry is through 1. Is it going to open up or down? Up. Is it going to be wider or narrower? Narrower. So I'm just going to do what I have so far. I know my axis of symmetry is 1. My vertex is somewhere on that line. And I know, what else do I know? My y-intercept is what? Awesome. Hey, guess what? If I know that my y-intercept is 2, I can very easily do what? Do you see what I'm pointing out to you? When the y-intercept is available, it's a great option. Because now all I have to do is figure out where to put the other coordinate. It's supposed to open up, so it better be what? Somewhere down here. If you calculate it and you get 8, it's wrong. Okay? So we just finish it up. We put 1 here. We do 3 times 1 squared minus 6 times 1 plus 2. 1 squared is 1. Times 3 is 3. Plus 2. So that's going to give you negative 6 plus 5. Are we good? Are we in good shape? 1. It, actually, yeah. Oh, guess what? I just taught you something. I didn't even know it. How do I know that that's not 1, 1? I just plotted my vertex wrong. Because that is basically the standard width, up 1 over 1, but I knew there was a 3 there. So I knew I did something wrong. I should have put the vertex at 1, negative 1. Do you see how all of these things can help you? Okay, so this is the final piece of 8-2. This is graphing parabolas in standard form. Do you understand now that horizontal